Dear students, how are you? Hopefully you are well. Today our lecture topic is chapter 8 and that is totally depends on the theorem, and actually this theorem is totally depends on the circle related. So let's start our today's class, and today this is actually lecture number 2, and today we will generally discuss about some basic of this chapter and 21, 22, 23 and 24 number theorem. So to start our as usual theorems, we need to actually go for some basic, and the first part is arc of the circle. First question is, what is the arc of a circle? So the arc of a circle will be, suppose if we are taking 2 points in a circle and cut from this point, then we may get looks like this part and this part. Suppose we have just cut the circle, then we may get these types of part. So here, since we have cut from this circle into this part, so here we actually get two part. Here is the major part and here is the minor part, and this is also known as the arc, and especially this major part is named as the major arc, and the smaller part is known as the minor arc. So I think you can understand that what actually the arc is. So arc of a circle must be the part of a circle by cutting from 2 points. Okay. Now our second part is, what is the radius of a circle? Okay, what is the radius of a circle? To understand that part, we can think about, this is the center of this circle. If this is the center of this circle, then from the center to the surface, if we draw a line, that is known as a radius. So this is a radius, and is this. So every line is known as the radius. So the definition of radius will be the length from the center to the surface is known as the radius, and radius is always denoted by r. Okay, so the radius is always denoted by r. Okay, now we are going for our third part, that is the diameter. Diameter is something which is generally two part will be added, and this line must have to be gone through the center. So radius is a line which must have to gone through the circle, and it must be double of the radius. So this is the diameter, and diameter is generally denoted by d, and the relation of this diameter and radius always d equals to actually 2r. So if we multiply r with 2, then we get the diameter. Okay, now the chord. It's a very, very important thing. What is the chord? Chord is very much similar to the diameter. Diameter is some line which generally touches two sides of a circle, and chord is also a line which generally touches two sides or 2 points of a circle. But the fact is, it generally not, or it obviously not gone through the circle center. So the line joining 2 points of a circle but not goes through the center is known as the chord. So every these 6 are actually known as the chord. And here this is also a chord. It's a very important thing. This diameter is also known as the chord, but the greatest chord of the line is known as the radius, diameter. So diameter is also a chord, and this chord will be the largest line. And it must be goes through the center is called the diameter. Okay, so if we are going for this way to find out the chord, so this all are chord, but this is the diameter and this is also the chord as well as this is the diameter because it actually goes through the center. So all are chord, but the chord which generally goes through the center is known as the diameter. Similarly, if you go for this way, so all are the chord, but this is the what? This is the diameter because it goes through the center. So and everything is the chord which generally touches 2 points of a circle. Okay, I think you can understand what's the basic difference between between the chord and the diameter. Okay, thank you. Now move on to our last two part, which is very important, and I'm just trying to actually draw all of this in a cycle. That's why I am very careful about erasing. However, suppose that was our circle and this is our center. So angle created in a circle or on a circle surface is known as the inscribed angle. So the angle which will be created on a circle surface is known as the inscribed angle, and if the angle created with the center is known as the central angle. Central angle must have to be created on the center, but inscribed angle must have to be created on the circle. That is the inscribed and this is the central angle. So this is inscribed, so we may write it I, and this is central, so we may write it C. And here I have been given a relation. What's the relation between this central angle and the inscribed angle? Always the central angle is equals to 2 times of inscribed angle. Okay, so the central angle always ties of the inscribed angle. So if our inscribed angle is 30 degree, then we can say our central angle must be 60 degree. So this is your class work, that is, if our central angle is 120 degree, so what will be our inscribed angle? How? Yes, just 2 into inscribed angle, so 120 divided 2 equals to our inscribed angle, so inscribed angle is equals to 60 degree. Okay, thank you. So this is the relation of inscribed and central angle. Okay, here, so the angle in a circle standing on the same arc are equal. This is our theorem number 21. So theorem number 21 says what? Angles in a circle standing on the same arc are equal. That means, suppose we are thinking that this is our required arc, that is the BD, we are thinking about this arc, and if we draw 2 angles on this arc, suppose BAD and BED, then these 2 angles must be equal. Why? Angles in a circle standing on the same arc are equal. Whose are equal? The angles are equal. Okay. Now our special nomination says the center O on the arc BD. So this is our center and our arc is BD. We are thinking about the arc is BD and center is O. Okay. So BAD and BED be 2 angles in the circle. Since we are thinking that our arc is BD, so on the arc BD, the 2 angle is BAD, that means this angle, and BED, that is this angle. So these 2 angles are also given. Now it's required to prove that BAD is equals to BED. According to our scheme, So BAD must have to equal to BED. Okay, now proof. In this proof part, there is talking about the arc BD subtend an angle BOD at O. So the arc BD subtend an angle BOD. So since here O is our center, so this for this O and BD is our arc. If we add BO and DO, then we get actually what? Central angle, isn't it? So actually we get a central angle. So BO and OD, that means BOD is our central angle. Here just I have been talking about a relationship between the central angle and the inscribed angle. That was the central angle must have to be double of the inscribed angle. So from that formula we can say that BOD, that is the central angle, is equals to what? The inscribed angle BAD, 2 into BAD. Similarly, our central angle BOD is equals to the inscribed angle BAD. And here from this equation we can say the left side is equal. That's why since our left side is equal, that's why right side is also equal. So from here 2 is done. So this equal this. That means this angle is equals to this angle. That is our proof. Okay, this is the theorem number 22, and this theorem says the angle in a semicircle is a right angle. So here what the angle of a semicircle would be a right angle, and what about the right angle? That means actually 90 degree. Okay, now we are going for a spatial nomination. Spatial nomination says the AB is a diameter with center O. So here is a circle. In this circle there is a center O and AB should be the diameter. Since this is also a chord which is actually goes through the center. Okay. Now the ACB is the angle. ACB is the angle of a semicircle, isn't it? Semicircle, that is ABC. This is a semicircle. In this semicircle, the angle ACB is actually subtended by the semicircle, and it's required to prove that our ACB angle must be 90 degree. Why? Because he is talking about that you have to prove the angle must be right angle. That's why you have to prove that ACB equals to 90 degree. Now the construction part says that we have to take a point D which must be located the opposite of C. What is talking about? Take a point on D on a circle on the opposite side of the circle where C is located. So where C is located, we have to take a point D which must be lie on opposite of C. Okay, now proof says that angles subtending on the arc ADB. So the ADB in this actually surface, the angle ACB is created, and this ACB must be half of AOB. Why? Because AOB is our what? Central angle, and ACB is our what? That must be the inscribed angle. So here the relation must have to be ACB, that angle equals to half of AOB. But in this part, since this is the diameter, so we can say this nothing but the 180 degree. Since the AOB is equals to 180 degree, or you may also write that these are two right angle. So the angle ACB is equals to half into 180, and here we get finally ACB equals to 90 degree, which is our required proof. So very easy theorem also for us, but here one thing you must have to arise in your mind, that is we are thinking about this angle and this was in our semicircle, and that must be on the surface ADB, where we have one concept we have to work, that is the inscribed angle and the central angle. But in this case central angle is 180 or 2 right angle, so you may write it the 2 right angle. So 100 half into you may also go for 2 right angle, that means 90 degree, or 1 right angle. You may go for this way also. Okay, thank you. Okay, so now this is theorem number 23, and this is very important theorem for this lecture, as well as this will be test for your the MT exam upcoming, and as well as your SSC exam too. So in this theorem 23, here the question says that the sum of two opposite angles of what? Of a quadrilateral inscribed, which must be inscribed in a circle, is two right angle. What? So here the sum of two opposite angles, which is the quadrilateral, and this quadrilateral is inscribed in a circle, and total angle must be two right angle. So now our special nomination is, suppose ABCD, this is our quadrilateral which is inscribed in the circle having the center O. So from here we have to prove what? We have to prove the opposite angle, the sum of two opposite angle. If we are thinking that this is our angle, so the opposite angle of it must be this, and according to our question we have to prove that the sum of two opposite angles of a quadrilateral inscribed in a circle is two right angle. That means this angle plus this angle is equals to two right angle. Similarly, here this is also the angle and it is also angle, so the sum of these two angles are also two right angle. So it's required to prove that ABC plus ADC, that means this two triangle, is equals to two right angle, and BSC equals to BCD, that means this angle plus this angle is also two right angle. Now we are going for our some construction. Here just AO and OC must be joined. Now we are going for our proof part. Okay, before going to our proof part, we are just re-summarize the fact that here we are thinking, or what is our given? Here is the given part of the quadrilateral. Quadrilateral is ABCD, which is inscribed in a circle, and this circle has the center O, and we have to prove that the opposite side, that means this plus is equals to actually two right angle, as well as this angle plus this angle equals to one right angle. And another thing, that is the construction, that is AO and OC must have to be joined. Now we are going for the proof part. Here, standing on the same arc ABC, so when we are going for the arc ABC, in this on this arc, this is our what? Central angle, and this is our inscribed angle. This is our central angle, this is our inscribed angle. So what's the relationship between inscribed and the central angle? Yes, you know that the central angle is equals to 2 into inscribed angle. Okay. Similarly, when we are going for this arc ADC, when we are going for the arc ADC, on the time the angle ABC, that will be our inscribed angle, and this angle, this is the reflex AOC. It is the very important thing. Reflex AOC, what does it means actually? Reflex AOC means that this was our normal angle, and the other part of that angle is known as the reflex angle. So the reflex angle is our central angle, and this is our inscribed angle, and here the inscribed angle must be double of the reflex angle. That's why we are writing here the reflex of AOC is equals to 2 into ABC. So this is our equation number 1, this is our equation number 2, and here if we are adding these two equations, then we get this part plus this part is equals to this part plus this part. Okay, but here what we have been just observing from here our total are circle, and we know here we may get the 4 right angle, because the sum of the angle from the circle is 4 right angle or 360. We know that from that part we can say that this 2 is equals to 4 right angle. Now since this is our 4 right angle, so this part must have to be 4 right angle. That's why writing this part equals to 4 right angle. If 2 is divided by both sides, then we get this part equals to 2 right angle. What we have to do? Proof. And since these two are the sum of these two parts are 2 right angle, then it similarly we can say the opposite two angle, the sum of the opposite two angle are also what? 2 right angle. My dear students, I am just trying to present this theorem very easily to you, because this theorem is very important for your upcoming all exams. So what we have been done, you should have to write right now the theorem so that you can get a very good result in your exam. So what we have been done, I am just going for the another re-summarizing for the proof part. That is we have to think for this this arc. When we are going for this arc, this angle and this angle will be calculated. When we are going for this arc, then this angle and this angle will be going for the calculation. Then just adding these two part and adding this two part, and this is our 4 right angle, then we get our final proof. Thank you. Okay, so this is our theorem number 24, and this is the last theorem for this lecture. And this 24 number theorem is also very important as 23. However, the theorem says that two opposite angles of a quadrilateral are supplementary. Four vertices of the quadrilateral are congruent. So if they are supplementary, so we have to prove that the 4 vertices of the quadrilateral are concyclic. Okay, what does the concyclic mean? Concyclic means con, that means same. Con, that means same. So concyclic, that means all the points remain on the circle. Similarly, when we are going for conlinear, that means all the point will remain in a straight line. That is called the conlinear. So this is conlinear, and if any point or if some point remain on the circle, that is called a concyclic. Okay. Here, special nomination of this theorem is, let ABCD the quadrilateral with angle ABC plus ADC equal 180. Since we are talking about the supplementary, the angles are supplementary. That's why ABC and ADC, that means these two angles from this quadrilateral are 180 degree or 2 right angle, what we have seen just proved before at the theorem number 23. Okay, so it's required to prove that ABCD are concyclic. That means a circle, if there is exist, then every ABCD, all points must have to go on that circle. Okay, now construction says ABC are not collinear. Since ABC are not collinear, yes, ABC are not collinear, that's why there must be exist a circle and the point must be go through the circle. There exists a circle which passes through the 3 points. Since these 3 are not collinear. Okay, we're thinking for AD is a line which has actually intersected at point E and our join C and E. So in the drawing part, we have been doing what actually CE is the point, or E is the point which actually cut by the circle, so that E is the point which actually intersect the point AD, and EDC must have to be joined. Now proof. At the case of proof, we can say that ABC plus ABC plus AEC equals to 180. Okay, but we know that ABC and ADC was 180, what was our given. From these two, we can say our ADC and ABC are equal. So AEC is equals to ADC. But it's impossible. Since it's impossible, since in the triangle CED, in this triangle, this angle and this angle are equal. So E and D points cannot be the different point. E and D actually cannot be the different point. That's why D point must be lie on the E point, or E point last have to be lie on the D point, where the circle will also go through the D point. So we can say that the D point must have to lie on E point. So there is no existence of that point. So from this here, we can say that therefore E and D point cannot be the different point. These two are the same point. So we can say the ABCD are the concyclic. So concyclic, that means actually ABCD, all the points are remain on the circle. So I am just going for the re-summarize for this proof part. In this proof part or total part, here since they are talking about the supplementary, that's why when we are going for ABCD quadrilateral, that's why this angle and this angle's addition must be 180 or 2 right angle. then when we are going for this triangle or this quadrilateral ABCD, then we are talking about this angle and this angle, the sum of these two are what, 180. So from that two part, this and this, we can say this angle is equals to this angle. And we are thinking that I think this is totally impossible. Since these two are totally impossible, so D point must have to lie on E point. So if D is lie on E point, then ABCD will be lie on the circle. So we can say the ABCD points are concentric. Okay, and that's all for today's lecture. Thank you, dear students, for being your patient, and hopefully you are doing your work, and that's all. Thank you.